In this video, we're going to discuss CRA models for whole number multiplication algorithms. So there's two algorithms we're going to talk about. One's going to be the partial products algorithm, and it'll be the standard algorithm that we're probably most familiar with. So we're going to start with the partial products. Partial products, right? Partial just means it's a part of something. The product is the answer to a multiplication problem. So the partial products, we're just going to record parts of the product along the way and then add those parts together, whereas the standard algorithm, we're kind of doing some of that adding as we go along. Okay. So for both these, we're going to start with partial products. We're going to talk about 12 times 27. I'm going to go back to the area model because that'll be our concrete model. So again, kind of what we previously looked at was essentially an informal application of the partial products algorithm. So breaking this apart by place value, right? Because you have a height of 12, you have a width of 27. So breaking this apart by place value and viewing this as, right, 10 rows of 20, 2 rows of 20, and then 10 rows of 7, and 2 rows of 7. So those 4 domains. Breaking that apart in that sense is viewing this kind of through that partial products lens, because we found we had 200s over here, we had 7 10s over here, 4 10s over here, and then we have 14 1s over here. Right, so we have 200 plus 70 plus 40. So 70 and 40 is 110, plus 200, 310, plus the 14 is going to be 324. Okay, so breaking that apart in that way, in those 4 categories, is kind of our concrete solution or concrete strategy for the partial products algorithm. The representational is going to be that box method, right? So this is just a drawing that replicates the area model, that concrete model. Right, so we do 20 times 10 is 200, 7 times 10 is 70. There should be a 2 down here. I just saw height of 12, not at 22. 20 times 2 is going to be 40 or 4 10s, and then 7 times 2 will be 14. Okay, we add those all together, we get 324. Okay. So kind of what this algorithm looks like, right? The algorithm is just a set of steps that we can move through to solve a problem. So for the partial products algorithm, it's going to look similar to what the standard algorithm is, but we're not going to have any of this kind of superscript notation up on the top. So we're not going to be adding anything up here. We're just going to be recording every single partial product that we find. So we start at the same point we started our ones place value. Here we think of 7 times 2, or 7 groups of 2. So 7 times 2 is 14. So we're just going to write down 14, right? The 1 in the tens place, the 4 in the ones place. Okay, so that's one partial product. And again, this 14, right, 7 times 2, right, 7 groups of 2 or 2 groups of 7. This is the 14 ones down here. Okay, and then similarly in our box method, right, we found that 14 there. So we're just writing these partial products down. Then moving on, we have 7, and then we have to interpret what that 1 means, right? So we don't just want to do 7 times 1 and write a 7 down. 7, that's 110, so 7 times 10 be 70, or 7 10s. We'll just write down 70. Again, here we have 7 10s. There we had 70 in our box method. Okay, so we'll move on to the next multiplier, and again, we need to kind of focus in on what that 2 means in regard to place value. So that's 20. So 2 10s. So 20. 20 times 2, that would be 40. And that'll be down here. We have 4 10s in that area model. And we have 40 in the bottom left-hand corner of the box method. And then here again, interpreting what those digits mean in those place values, we have 20 times 10. Right now, just 2 times 1, 20 times 10, which will be 200. Okay, so here we've just written down all 4 of our partial products. And again, we just want to add those together, and we can just use that standard algorithm or whatever algorithm we would need for addition. So adding our ones place values, we just have 4. Here we have 1 plus 7 plus 4. So that's going to be 12, right? So here I actually will just kind of use the standard algorithm. So if we have 12, right, we want to keep the 2. Those, in this case, those 10 10s would be regrouped. Right, we're going to keep those 2 10s, and then 10 of those 10s will be regrouped into 100. So that's where I put it in the 100th place. So you get 324. Okay. And again, that's what we found in this, in the area model, and in that box method model. Okay. So kind of to compare that to the standard algorithm, essentially the only thing that changes is rather than thinking of this in terms of these 4 distinct domains, in the standard algorithm we do 7 times 2 and 7 times 10 all in one step. So we're really kind of looking at like 7 groups of 12 or 12 groups of 7. Okay. So for this one, I'll try to scoot this up a little. Use this one. Right, in the standard algorithm, we're just viewing it kind of in these 2 domains. Okay. So instead of having 4 partial products, right, we'll just have 2 partial products. Okay. So in our standard algorithm, again, we start in the same way here. We do 7 times 2, 7 groups of 2, so that's 14, right? Kind of similar to what we found in the partial products. But in the standard algorithm, we're going to regroup along the way as opposed to only doing it in the addition step. Okay, so this 14, these are still these 1s down here, right? These 14 1s. We'll just touch through and see them. Right, those are those 14 1s. So we know we have 14 1s. But what we're going to do, we have 14 1s, so we know 10 of those 1s can be regrouped into a 10. Okay, so we'll keep 4 of those 1s. But then the other 10 1s, we're going to regroup that as 110. Okay, so you won't necessarily always do this in the area models, but basically what we're doing in this step is we're just taking, move this around. Right, so we're mixing the organization of the area model up, but we're still going to keep the same total number. So we're exchanging those 10 1s for a 10. So we want to add this one on later, so I'll kind of keep it to the side. Okay, so then go back to the algorithm, then we do 7 times 1 or 7 times 10, so that'd be 7 10s. But then we had this extra 110 that we needed to add on, right? That was that one we put up there. So we don't actually have just 7 10s, we have 8 10s. Okay. So that's just that regrouping, but I wanna go back to the original structure just so we don't lose it. Okay, so even if we don't physically regroup that, that's kind of how we're visualizing on the algorithm. Okay, and you might notice here at this 84, that's just the sum of those first 2 partial products in the partial product algorithm. Okay, so we're just kind of eliminating some steps. And then moving on in the standard algorithm, it's kind of a good idea. Once we've added this 10 in, to either cross it out or put a dash through, just so we know that's not something that we need to add on later in that standard algorithm. So then we can move on to our next step. So, and then in this next step, right, oftentimes you'll hear, well, we need to add a 0 there. Well, for why we need to add a 0 there is, again, kind of based on what this 2 means. So this isn't just a 2 times 2. This is 20 times 2. So since we're multiplying by 10s, we know we can't just have any left alone 1s. Right? All multiples of 10s will have 0 in the 1s place. So we'll have some number of 10s. We just don't know how many. So we'll do 2 times 2. Okay, so that'll be 4 10s, or 40. So 20 times 2, 40. And then since we only had 4 10s, right, we didn't have more than 9 10s, so we don't need to do any regrouping here. So then we just do 20 times 10, or 2 times 1, right, to get to 240 for the second line. And again, you'll notice in that partial products algorithm, right, that's just the sum of those last two partial products, the 200 plus 40. Okay, so then in the standard algorithm, then we just add these two partial products. So 4 plus 0 is 4. Here we would have, right, 8 plus 4 is 12. So we have 12 10s. We'll keep 2 10s, and then 10 of the 10s will be regrouped as 100. And 1 plus 2 is 324. Okay, so this 84, right, just aligns to this category on the right in that area model. And then this 240, right, this is a little easier to see, right, with the 200s and 410s is just the left half. Okay. We don't necessarily do the box method to align with the standard algorithm, but kind of what that would look like, right, is that we would just have let's line the other way. We just have this full length of 12, 7, and then 20, right? So 7 times 12 is 84, and then 20 times 12 is 240. So we don't necessarily use this representational model too much with the standard algorithm, but that's kind of what that would look like. So again, those are both the kind of main algorithms for whole number multiplication. There's others, but these are the most common ones. But again, you kind of see how they're doing the exact same steps, but just kind of in a little bit different order. And also how they both kind of relate to that area model.